Hi everyone, Miss Donaldson here. Today we're going to continue discussing solving systems of equations using the method of elimination. Remember on last week we discussed elimination in terms of getting rid of. Remember, when you're looking at a system, you have two equations written in standard form. So you're going to have x and you're going to have a y. Remember, in order to eliminate one of those variables, you got to find its opposite. Or in other words, you must have one term that's the same, but the charge will be different. In other words, one will be positive or one will be negative. So looking at this equation here, I notice that I have a set of opposites. If I look, it's not my x's because I have x and then I have 2x. But look at my y's, I have negative y and I have a positive y. Remember, this here is what forms my zero pair because I have a positive y and a negative y. Now, because they're the same terms, they're opposite, they're going to form zero pairs. So those are gone. They are eliminated. So now I'm going to go back through and I'm going to combine or add the rest of my equation. Now, before I start to add, I'm going to look at that first x in the first equation. I notice I do not see a coefficient or a number in front of that variable. Remember, when I don't see a number, it's understood that a 1 is there. So I don't get confused on my addition. I'm going to go ahead and write that coefficient of 1. Rather be safe than sorry. So now I'm going to go back through and I'm going to combine the like terms or add those together. So 1x plus 2x, I add my coefficients. So 1 plus 2 gives me 3. And then my x's are going to stay the same. Remember, my y's are gone. They're out of here. So now I'm just going to add 11 and 19, which gives me 30. Now, it becomes a solving equation type problem, right? So if I look beside my x, there's a 3. Side by side means a multiplying, right? So the inverse to multiplication is going to be division. So remember, I got to keep my equations balanced. So what I do on one side, I have to do on the other side. So I'm going to divide both sides by my coefficient, which is 3. This simplifies to be 1. And because you guys are so smart, you know that anything times 1 is going to be itself. So 1x is just going to give me an x. So when I divide 30 and 3, that gives me 10. So my x of my solution set is going to be 10. I have the first part of that. I am not done. You're thinking, Miss Donaldson, you got to find your y. You are correct. Remember, you're looking for a solution set that has an x and a y because that ordered pair will tell me its intersection. Now, in order to go back and figure out what that variable I eliminated, what its value is, I'm going to choose one of the equations in my original solution. Remember, it does not matter which one I choose because I'm going to get the same answer. I'm just going to take the first one. So my first original equation was x minus y equals 11. I'm going to go ahead and substitute the 10 in for x minus y equals 11. So from here, I just solved the equation. But if you'll notice, I have the constant or the number listed first. When I have my constant written first, I check the charge of that particular number to determine my inverse. So if I look here, I have a 10. There's no sign in front of it. You guys know when you don't see a sign in front of it, we know it's positive or like I'm adding. So my inverse is going to be to subtract 10. Like we discussed before, to keep your equation balanced, what I do on one side, I'm going to do the same thing on the other side. So that forms a zero pair. I'm left with negative y equals 11 minus 10, which is 1. Now, as we discussed on last Thursday, we want to make sure that our variables are positive. We discussed you guys remember, how can I keep my y the same and then change the charge? Then we got a discussion about 1. Remember, 1 times any number will be itself. So I know that in order to keep it y, I got to multiply it by 1. So I'm going to go ahead and write the 1 on the outside. But not just 1. Remember, I also need to change the charge. Then we got a discussion of what happens to the negative. Remember, anything times a negative is going to change the charge, right? So instead of me multiplying by 1, I'm going to multiply by negative 1. Remember, multiply by negative 1 will allow the y to stay y, but it would change the charge to a positive. So negative 1 times negative y will give me a positive y. And then 1 times negative 1 will give me a negative 1. So in the system, y equals negative 1. Now, let's go back and let's write this as an ordered pair. Remember, when you're in your ordered pair, x and then y. If I was you guys, I will make sure I list out x and y so I don't get confused. Remember, the first value will be your x in your ordered pair, and your second value will be your y in your ordered pair. So let's check in and figure out. The x value that I just found was 10. So that's going to be listed first in my ordered pair. And then my y value was negative 1. So my solution set is 10, negative 1. Again, that ordered pair lets me know where those two lines will intersect. Remember, their intersection is that point that makes both equations true. Now, let's continue with today's material. Today we're going to look at what I need to eliminate, but I don't automatically see a zero pair. So what should be my steps in order to form a zero pair in order to eliminate? So our example here, we have 8x plus y equals negative 16. And then we have negative 3x plus y equals negative 5. If you're like me, my eyes automatically go straight to the y's because they're two y's. But where they are now, I cannot eliminate them because they're both still what? They're both still positive. So I need to, in order to form a zero pair, I need to make one of those a negative. And if you guys remember, going back to the last example, remember here with the y's, what did we do? Remember, in order to change the charge but keep it the same, our magic number was negative 1, right? So same thing is true on our example here. We need to multiply one of these by negative 1. Remember, negative 1 would keep the term the same, but it would just change the charge. So I'm just going to choose the second one. Again, I could have chose either one, and I still would have got the same answer. So I'm going to multiply it by negative 1. Now, if you'll notice, I have my original equation inside a set of parentheses, and I have a negative 1 on the outside. You guys should know by now, when you see an equation set up like that, I'm going to have to distribute. So I'm going to have to multiply negative 1 by everything inside that parentheses. So I'm going to rewrite my system, and I'm going to write it in a different color so we can see it. So since I did not do anything to my top equation, that's going to stay the same. So it becomes 8x plus y equals a negative 16. Now here, I'm going to do it in orange so you guys can see where I distribute. So negative 1 times negative 3x would give me a positive 3x. Then that negative 1 times that y would give me a negative y. And then that negative 1 times negative 5 would give me a positive 5. Now if you look, I have what? I have zero pairs. So now it's back to solving. Now I can eliminate and then go to the same steps. I'm going to combine or add the remainder of my equations. So 8x plus 3x gives me 11x. And then on this side, I have negative 16 plus 5. Remember, different signs, you got to find the difference, right? Because you're going to end up forming some zero pairs when I group them together. So 16 minus 5 will give me 11. Remember, you take the sign that has the highest absolute value. Or you guys may say the larger number. So if I take away the signs and just compare 16 and 5, my larger number is 16, and that has a negative sign in front of it. So no matter, it's going to be negative 11. So just like our first example, it becomes solving the equation. So I have a number written beside a variable. I know that means to multiply. So my inverse is going to be to divide by that coefficient. Again, that becomes 1x. Anything that has 1 is going to be a sub. So I'm left with x. Then on this side, negative 11 divided by 11 will give me a negative 1. Got ahead of myself. So that's going to be x equals negative 1. As with before, we're not done. I just have part of my answer solution. So now I need to go through and figure out what that variable was, the value of the variable that I eliminated. So remember, you can choose either one, but for this purpose, I'm going to choose the second one for a reason. If you remember, I had to go through and I had to multiply everything by that second equation by negative 1 to form the opposite of that y. But when I'm going to go back and solve for y, I'm going to actually use the one in red, the original, not the one in orange, when I go back to figure out what that value was. So it's going to become negative 3x, because again, I'm going to use the original one, not the one multiplied by the negative 1. I just figured out that x was negative 1, so I'm going to substitute that negative 1 in for the x, and notice I multiplied. Remember, when you have a number right beside a variable, that means to multiply. So when I plug in that negative 1, I must notate that I'm going to multiply it by 3, negative 3. Plus y equals a negative 5. So negative 3 times negative 1 gives me a positive 3. Plus y equals negative 5. Now, again, go back to our first example. My constant's written first. So remember, check the chart of your constant in order to figure out whether you need to add or subtract for your inverse. I have no sign, which makes it a positive. So my inverse is going to be subtraction, right? So minus 3, minus 3. That becomes a 0 pair. I'm left with y equals, now over here I'm subtracting. Now my rules are going to change. I got to keep it, change it as you guys say. So I'm going to keep the first one, which is negative 5. That subtraction is going to become a positive. And then I'm going to change the charge of that 3. There's no sign in front of it, so that lets me know that it's a positive. So my inverse is going to be a negative. Now, go to my addition rule. I have same sign, so I'm going to add and keep. So 5 plus 3 gives me 8. And then it's going to stay negative. So my solution set for this particular ordered pair will be listed as, remember, x first, then your y. So the x will equal negative 1. And then my y will equal negative 8. Let's do one last example where we have to create a 0 pair. My example here is 7x plus 2y equals 24, and then 8x plus 2y equals 30. Again, my eyes go straight to the two y's because I have two y's. But again, as they are now, I cannot eliminate those because they're both positive. So as before, I'm going to have to multiply one of those by a negative. So I'm just going to choose the top one. Again, I could choose the second one. I still would have got the same answer. So I'm going to multiply everything by negative 1. When that happens, it becomes negative 7x and then minus 2y, because a negative and a positive gives you a negative. And that's going to be negative 24. Then down here, since I did not bother that stays the same. So 8x plus 2y will give me 30. So that's the 0 pair. Now just go through and combine my like terms, or add my equation, right? So negative 7 plus 8x will give me a positive x. Remember, different signs, find the difference, take the one with the largest absolute value, which would be 8. So it would be positive. And then on this side, I have negative 24 and I have 30, right? So let's say that you owe me $24. But someone was so nice that they gave you $30. So not only do you have money to pay me back, but now you have $6 left over. So that's going to become a positive 6. So the x value in that solution set it's going to be a positive 6. But again, I'm not done. That is only half of the solution set. So now I have to go back and figure out what my y is. So I'm going to take one of these and use it to find my y. I'm just going to use the second one, right? So it becomes 8x plus 2y equals 30. Again, I could have chose the first one. I still would have got the same answer. So again, I'm not going to plug in x. I'm going to plug in 6. So plus 2y equals negative 30. Now, 8 times 6 gives me 48 plus 2y equals negative 30. Oh, excuse me, I put negative 30. Should be positive. I don't know where I get negative from. So you wrote negative, erase that. So it should be positive 30. Okay, so now I'm going to subtract 48 from both sides. So minus 48, minus 48. That's going to be a 0 pair. So I'm left with 2y equals negative 18. Because now here's the opposite. Now here you have $30, but you owe me $48. So not only do you have to give me all the money you have, but you're still in debt to me for $18. So it makes it negative 18. So now solve the equation. Divide by 2. So my y will equal negative 9. So my solution set for this particular one will be, same deal, 6, negative 9. Now, again, make sure you label x and y, because right now, so far, everyone we got rid of was the y. So our first answer was the x. But you may have instances where you have to get rid of your x's, and then the first one you saw will be a y. So make sure that you listed x and y so you know exactly where to place it in your solution set. I hope you guys enjoyed it. I hope it helped you guys. Remember, going to our EQ, how do I solve system using elimination? Remember, your first deal is to eliminate, right? So we got to first figure out or find a 0 pair. Remember, today we did an example of both, to where they're already there. But remember, if it's not there, you have to create your 0 pair. If your terms are the same and they're the same sign, remember, do today's method. Just multiply one of those by negative 1. That will give you the opposite that you need. Then that will allow you to eliminate one of those terms, x or y, or variables rather, x or y, and then you can solve the equation. Then remember, go back in, plug in your new variable, the solution to your variable, into one of your original equations in order to find your eliminated variable. Remember, then you have both answers, and then those become your solution set. Remember, your solution set is the intersection to where those lines meet, or the points that make both of those equations true. Alrighty guys, hope you enjoy.